is the next steps? What is into the future? And you guys are going to actually to make the difference in the future. And that's so good to be together with students, because then we know that they will keep on the good track for a long time. I thought to show 3 different scales of projects, because I'm happy that I'm also not only teaching, I'm also happy that I am practicing. And then I will show 3 different scales of projects that could maybe be a little bit on the way, step to the future. And then I would start actually with the smallest part, whereas we have, for many years, we have tried to make sustainability and environmental thoughts in our project in Snøhetta, but it's actually pretty hard. Sometimes you can have these great ideas when you're making a competition, but it comes to the real work that you're actually going to execute it. It's all about all the different layers that has to be there. So when we got into, in 2008, we got into something called Powerhouse and SEB, Zero Emission Buildings. We were part of a group that actually has all, it's transdisciplinary, it's interdisciplinary, it even have the contractors and the people that are actually going to use the project afterwards. And I think that is maybe the key issue. It's not enough that we as urban designer, landscape architects or architects say that we want to do something. We need the whole team, and everybody actually needs to be on the same track. So this Powerhouse has its main definition. It's a building that during its life cycle, which is really important, the whole life cycle, it produces more renewable energy than it consumes for production of the materials, construction, operation, and demolition. So you have to think in a whole lifespan. And for this, we use 60 years, which you can think of how old will you be in 60 years. Okay, you will all be pensioners, can come back to SUDes and talk about the great work you have been doing in 60 years. So that is really important, to have the lifespan and to think in the long term. So when we got into this system, which is really a collaboration of a lot of people, and it's a research part of it, which I also think is really important, because to be alone, it's really hard to do it. But if you're in a big collective, so this is for 5 to 8 years, and we've been working with a lot of different firms, and we have some pilot projects. So one of those projects is the SEB pilot house in Larvik. Larvik is in the southern part of Norway. So there is always a site. So even if it's a pilot project, it is a site. And we have to take the condition for the site into consideration for the project. And if you think, if you're going to make like the less energy used, it's really just a box. So if you have the box, but you really want something more. And for us, the comfort was really an important issue. And what is actually comfort for a single family house? For us, we thought it was really important to think indoor and outdoor. Really, how can you use this during summer, during winter, and how you can actually be together with your house. So we said that the most important criteria is site, view, indoor-outdoor situation, energy harvesting, living comfort. And also in this comfort, we thought that people that would live here, they would actually think of comfort as that they would know that all the materials were really healthy and it had a lifespan and they had that part of their environment. So of course, the architecture is an important issue. So we said that the indoor-outdoor situation is really important. So we cut it off to make a cave, to have an atrium, to have a place that is shaded and could be sunny and could be warmer. So also, how to harvest energy. You could say that maybe 45% degree would be really a good angle to harvest the solar energy, but that is a little bit hard because you get a lot of extra space. So we figure out to actually optimize that to 19 degrees. So our project was the box that we carved out to get this indoor-outdoor situation, and it's a sloping roof. And here's actually the building. You could say this looked like pretty much a normal house, but it has in consideration all these things that a powerhouse needs to do. So just for the outer area, the pool is actually an old tank that was divided in two and a totally reuse. For the material, all the single material in this project has gone through everything in the lifespan, how it's executed, how it's produced, and how it will be reused again after it's demolished. So for you could say, how could you take railroad tracks from Australia and say that is sustainable? But they were already transported to England, and they then were transported to Norway already, and we said that these actually is the reuse to make in a new way. So they used to see the kangaroos in Australia, and now they actually could see the reindeers in Norway. And the format of indoor-outdoor, because we thought that actually a fireplace is maybe the most important that we find for the comfort in Norway, because we need it for the winter time and we need it for the long, dark nights. So actually to have the fireplace outside was more important. The thermic mass reuse of bricks, and how actually all the materials all together with the sloping roof then create this house. Short travel for all the materials that is outdoor. For the gabions, it's taken from a site that is like 5 kilometers away. And then to have this on the site to do. And we then, after all the calculation, it actually produces more energy than it needs. So we could be actually on the net. And the wood that you could take away from the facade, then use for your fireplace. So this was the rendering, and this is the finished project. The best thing about this project, I think, is that it's a pilot, and it's actually then people will go and look at it. So people that is not just architects, it's the builders, it's the contractors, engineers, and really all the handcraft people, because I mean the plumbers, they go to see this, how it's done. And that I think that is part of the learning process. You need everybody to take part of the process. And then of course when we saw all the insects that actually love the way the wood was treated, we said that it's insect approved, so it has to be good for the future. And they moved into the garden. Another level is actually to go into the landscape and then to think of how we use the earth, the dirt. And I think maybe that is sometimes too many times it's forgotten how the in-between rooms are actually treated. We have been working with a project here in Lund, Max Lab 4, that is synchrotron. It's a research library. And it's actually the buildings have BREEAM Sweden certification outstanding. It's 50,000 square meters of research buildings. And it's also got this Miljöbyggnad Guld, which is based on energy use, interior comfort, and materials. And the bonus is actually the 19 hectares of park, because they didn't ask for any park. They didn't ask for how the outdoor areas should be. They didn't ask for, in this really important area, which is the new science park in Lund, that they actually could even get a park. So this is northeast of Lund center, and it's really in the transformation area that is really going to be the new city of Lund. And if you see it's this new synchrotron radiation laboratory, and it's already here at the university, but it's moving over there. And if you see the Google picture, it has this fantastic fabric of cultural landscape. And the circle, almost the medieval Lund, this is really on the edge. And it's like a peek to the future, how actually the new Lund will be. The thing about this landscape, it's really flat in Skåne. So they figure out on the site that is a highway. And if you drive on that highway and you pass over a stone, it will make vibrations in the ground. And to split light into atoms into electrons to make synchrotron light, because that's what the research library is doing, it really needs to be still. It actually can't tackle no vibrations in the ground. So the researchers were really afraid that they actually could use the site. And you know, sort of traditional landscape architecture, you need to have mass balance. The thing you cut off, you need to reuse them. And in Lund, the city municipality, they're very strict. If you take any of the dirt out of the site, you have to pay a penalty. And the dirt is such a fantastic parameter to work with, so we wanted to reuse that. And all the water runoff has to be kept into the site and needs to be reused. So we had already these two sort of traditional parameters. Now we had also this with the vibrations. So what we did, we said, we have a really flat site, it's really gentle sloping, and we have the ring that is 600 meters in circumstance that need to be protected. And then all the tangents, that's where you take the light off of to actually create the radiation. And then we based one set of parameter, because they say the wavelength in the vibrations in the ground was between 10 and 40 meters. So we used that as the parameter. So we had 2 sets of parameters that we would use to actually excavate all the soil and then reuse them. So we made this parametric pattern to actually make new waves in the landscape, because the more surface on top, the less vibration would go into the ground. So from the flat landscape, we made actually a totally new landscape that also was based on the wavelength that was actually for the vibration in the ground. So we could actually put the Rhino model straight into the GPS of the bulldozer and execute it. So 1 cut of the soil into the new mounds. And most of the landscape were executed between May and September, and you have a wonderful landscape. So in September, with snow on top, now you can see the building starting to get there. The laboratory has 150 seats, and it's actually all green on top. And then we were talking about, this is very high-tech, how we actually did the earthworks, but what it will be on top. So this is not a golf course, so we were looking into the area that actually there is a natural reserve just 5 kilometers away, Kungsmarken. And there's a beautiful meadowland. 80% of the meadowland in the southern Sweden is gone away because it's a monoculture area. So now we said if we cut the hay and then transport it over to the new site, and we will make all the plant selection that is naturally grown for hundreds of years, get it back on track on what used to be the agriculture land. So here is the hay, and this is on the new modes. And when you go close into it, takes 3 to 5 years to actually make all the meadow vegetation grow up. You have some flowers the first year. It's really kept well. It's 5 centimeters of the hay on top. So you go into this really traditional and low-tech way of actually reused existing vegetation that is already in the area. And then the water runoff makes a really nice new pond. We had some fish inside it, so we hope that they will start now to be part of the laboratory. Okay, the last project is looking into the future, and then we go to the master plan level. So the park here in Lund will be a folk park, will be the first step to make a totally new transformation of the area with a lot of mixed use, a lot of people living there. The governmental quarter in Oslo, that's a master plan we did work with this spring. And we called our project Folk, people, because it's all about people. The governmental quarter in Oslo is really downtown in the most urban area of Oslo. And because of 22nd of July 2011, the terrible thing that happened with I would call it a terrorist that actually bombed the area, we had a situation that we had to rethink. And then now this spring there were 5 teams, and 1 team that was actually based on a student cooperation between the School of Architecture in Oslo and Columbia University in New York. They were the 6th team. So how do you then plan for a long-term plan for a new governmental quarter? What was really interesting here, we had to first look into 2024 to 2034, which means that it should be 7,500 people working in this governmental quarter. And then we had the long span, 50 years, 2064, with 8,300 people working at the same spot altogether in the most urban area, in the most important maybe area in downtown Oslo. And of course, there was an extreme parameter about security. What happened should never ever be able to happen again, and how do you treat that with the urban life? In the urban realm, where you really need people to meander through. So they had also some complication. We had a tunnel below grade, which also was a security problem. And then of course the function, that's great. The program said street life, and street life. How to make an urban plan that actually could function. So for the urban design, this was really important and not so much about the architecture. But to have all these people with 20 square meters per working space, it meant that it has to be pumped up to an enormous number of square meters to work with. So we said, there are some site findings that is really interesting here. We had this red dot, you are here, which is an existing plaza called Youngstorget. Which was not part of the program, but which we figure out that it's a functioning plaza, we have to reuse it. And then we had the axis well-functioning north-south, but totally not functioning east-west. So we had to really densify and minimize the footprint, and then of course we get really high towers. There needs to be high rises to actually make this happen. And we were working so hard to actually make the footprint so small so we have as much park and street life as possible. So we said that actually the existing plaza, that's where the entrance is going to be, that's where all the people can walk to go through. So we get an indoor-outdoor situation. You walk underneath, below, above, and on the side of the whole project to actually make sure that people will use the area. So the old existing building that is there has now 3 enormous towers, which is not common. We have a couple of high-rises. It's not really high-rise, it's just 26 floors tall in Oslo. And you see the building in the back, that is what is called the high block that is already there. And then you pass underneath the existing plaza, the arcade. You can walk inside the building, and that's where the entry and the indoor-outdoor room will be. And you keep on walking and get to a new park, a new city park that will be part of the governmental quarter. And then it should be not just a park, but actually a forest. We wanted to recap to have a forest inside the city. So the car traffic was the first parameter, because the security issue was you can't build closer than 20 meters from a car trafficked street. So we said, get rid of all the car traffic and make the green mobility the most important. And then the people that are walking will actually protect the governmental quarter. And then we actually solved the security issue to make sure that people were walking and not driving part of it. So the green park, also not to have too much built below grade. So actually the park, the trees, the plants can grow in Mother Earth instead of on top of roofs. And then of course minimizing the footprint to really work on how to harvest energy and make the shade as little as possible. That's why we have the triangular shape, to make as much sun as possible. And then for the harvesting, the solar panels, the green roofs, and also the facades. And that's actually now how the project stands. This was a parallel commission, so there were no winners, but they are working with how to plan for the next 50 years. And with our project, we calculated that it would produce more energy than it actually used. So that was also part of the whole calculation for the project. So, and we thought that it would be nice to have the skyline, that you can see it for a long distance, that this is actually a sustainable project that should light in a new way to show how the future could be.